All right, so this is the session for Lathe inside of BobCAM for SolidWorks. This is V9. I'm using SolidWorks 2021 Service Pack 3, but you should be able to use this down to, I want to say, SolidWorks 2016 or so. So you can go back a ways. All I've done so far is I've opened up a part file. So I've opened it up. Now, before we get started, you have to define the coordinate system on the front face of the part here. So the way I do this, and I am not very good with SolidWorks, so my method might be longer than it takes to a normal person to do this, but I'm going to do it the way I've been doing it for a long time now. So the first thing I like to do is kind of line up my X and Z axis. So I'm kind of looking down on them, and I'm looking at the coordinate system down in the bottom corner. And I'm just going to start by creating just a planar surface right over this hole here. And then I'll hit OK. And that gives me now kind of a plane that I can use to sketch on. So I'm then going to click on that surface and say I want to sketch on it. And that's going to create this little sketch plane, essentially. So now what I could do is I want to go from the center of this surface and make a line that goes straight out and another line that goes straight up. So just line from the center straight over to the wall, and just want to pick that point right there. So that's going to represent my x-axis. And then this one is going to represent my y-axis. Now that sounds odd, because why would we be using a y on a two-axis lathe? It's x and z. Well, the reason I do it that way is if I exit my sketch, now I can go in and define a piece of reference geometry. So I'm going to say insert, reference geometry, and then a coordinate system. And so the selection is going to be off that point right there. And then I have to go and define my X and Y axis. Now, Brock, if you're using the standalone version, you won't have to do this. You'll just make sure your part is laid down on the left side of the crosshairs. So you want the front face of your part right at XYZ0, and you want it centered on XYZ0. Because really, when we define turning, we're only really looking at half the part. We're really only looking at kind of what you pick, because whatever you pick on one side is going to get revolved and cut the same way. So now I could go in and say that my x-axis is here, and you could actually see it's already defined properly. But just to run through it again, let's get this looking the wrong way. That's the right way. That's exactly what it's supposed to look like. So if you were to open up a part and your coordinate system was wrong, you would have to come in and tell it, all right, my x-axis goes this way. My y-axis goes this way. So now we have our z down the middle of the part, which this part is already designed to do that. So it's not something I really needed to change. I probably could have gotten away with this without even adding a coordinate system. But, you know, parts don't always open up in the correct plane. So it's best to know where you need to put them. Basically, if you're using the standalone, you need to make sure that the front face of your part is along the X and the Z right at the crosshairs. Any facing material that you create is going to be added in front of this origin or in front of the origin of the standalone. So I'm going to just hit OK. And now I have my coordinate system that defines my X, Y, and Z. Or really, for me, it's just my Z and my X. So now I'm going to go ahead and do one last thing, which is I'm going to add a point to the center of this back surface. And that is strictly for the, let me go ahead and blank this stuff out. That is strictly for the, what you call it, the cutoff. Sorry, totally forgot the word. The cutoff has to have a point in the back of your geometry to know where to cut off to. So I'm just going to go in and pick that surface and say I just want to sketch on it, and I'll just take a point and slap it right on the origin because it finds it right there. Again, if you're doing this inside the standalone system, you won't have to do any of this added geometry because you're going to be using wireframe. Wireframe has snap points. You can use snap points for your cutoffs. All right. So there we have it. So now I can go over to my CAM tree here, which is right over here. And I'm going to start by right-clicking on CAM defaults. and then I'm going to go down to new job. This is where we define these steps right here. If you are using the standalone, will be essentially the same steps. The stock wizard's going to be a little different, but it should match up pretty well. So if you don't have a part on your screen, you could do something as simple as just from the, well, let me get rid of some stuff here real quick. Close this down. Good. You can go. If you have the crosshairs, just draw a line that goes from the in your upper left-hand most quadrant. Just draw a line on an angle, or unless you have a turning part, but just draw a line on an angle, and that's enough for us to define some stock and do everything we need to do. So I right-click on CAM defaults. I say new job. And then I'm going to go and say start the stock wizard, or sorry, we got to choose turning first. Now, turning always picks a machine called the BC2X lathe. It's just our BobCAD 2-axis lathe. It's a good lathe. It works for just about every lathe that exists because we're going off the front face. There's a lot to it. But with the BC2X lathe, the only thing you really need to make sure of is that you have the correct post processor selected. By default, it's going to pick a generic post, but if you've worked with the post guys or you've downloaded a post that's one of our OEM posts, if you got like a Haas lathe, we have a post that already works for that. You won't have a machine that specifically says Haas lathe, but you should have a post that works for the Haas lathe. So that's kind of how it works. And I'm going to go right into the stock wizard. We'll hit OK. Now, a lot of times with lathe parts, turn parts, you don't actually have a solid model, but being in SolidWorks, we always have a solid model because we're always drawing with a solid model. So I can pick my solid model there, and that will be my work piece. And then I can go and hit this next arrow right there, or in your case, might go down to the bottom and hit the next arrow. From here, we have to choose our coordinate system. So it knows where the front face of the part is, and it creates it that way. In the standalone system, you don't need to do this. So you don't have to do this. You just need to make sure your part is oriented correctly. And so for me, I'm just going to expand this and say I want to choose the coordinate system for that. So now it knows which direction is kind of my X and my Z. And then for my diameter, I just have to make a diameter that I'd be willing to start with on a job. So for me, this could be 2 1/4. Gets us a little bit of extra meat right outside there. It's a piece of stock that I can turn that to size real quick and easy. And then right here, it would be if we had a hole down the middle. So if you're starting with a piece of stock that has a hole in the middle, you can define what size that hole is as well. All right, and then finally, we have the length of our stock. So it's from the front face here going back. It does not figure out the size of your stock. It doesn't work like mill. Like with mill, we have rectangular and all that stuff. It doesn't work that way with lathe or with turning. You're going to have to define the diameter and the length of your part. So I'm just going to say that it's 4 inches long. And then right here is my stock origin. This is how much material I have basically sticking out in front of the origin, the amount of material I want to face off when we face this thing off. So I'm going to go ahead and just say there's 100 thousandths. Now what that does is it just shifts this stock forward. Right now from here back to here is 4 inches. But when I get out of this box, it's going to shift it forward. So from the front face, back is now 3.9 inches, and I'm going to cut off 100 thousandths off the front face of that part. All right, and it works just like the facing does in the milling setup, where you can essentially not pick any geometry. It's recognizing this material in front of the part as face material. It's material that has to come off, so you got to make sure you set it up properly. Finally, the last bit is setting up the machine setup right here, which is our coordinate system. Once again, it's the same exact thing. And then you'll have your clearances. So you have your face clearance, which is 1 inch. You have your OD clearance, which is 1 inch. So these are your areas where the tools will rapid around the part. This is kind of where they return to rapid. And then for ID work, it's 50 thousandths. So it's going to pull that tool off the wall, just 50 thousandths, and then it's going to feed out. So it hopefully is small enough to be safe. When we're done and we can't hit that next arrow anymore, we're going to hit OK. And that's going to lock that stock in. So after we're done with that, if we expand stock, we can see the material. And right now I'm using a 6061. The problem is turning does not rely on the feeds and speeds calculations that BobCAD usually enters. So this would be something you would have to do some research or use a program that tells you what feeds and speeds you should be using. Because it doesn't calculate this for you, or you're just going to do some testing and find out what works. The only time that the material is important is whenever you're doing a drill or like a center drill, tap. That's going to be important because that will have a specific, we do calculate feeds and speeds for those tools. All right, so if it's a tool that can be used on both mill and lathe, then if it's a milling tool, then you're going to most likely be able to get your feeds and speeds from BobCAD. So you do want to make sure your material's set up correctly. But if you're going to manually enter feeds and speeds regardless, it really doesn't matter what material's shown right there. Because if you're manually defining them, then there's nothing to mess with. So I want to just make one quick change here. Settings. User interface, CAM. I want these guys on the right. All right, apply and OK. All right, I like my blank and unblank stuff on the right side of my text. So there we go. All right, so we have the stock created. We have the material defined. Now, one thing that I do strongly recommend is setting up tools beforehand. All right, and what you'll see now, if you are using the other version, if you're using our standalone version, the CAM tree is the exact same CAM tree. So we can go create our tool crib. We can do, pretty much everything's the same from this point forward other than picking geometry. So I'm just going to start by right-clicking here on Turning Tools, and I'm going to go down to the tool crib. All right. Now remember, the tool crib is the area on this specific part where we define what tools we plan on using. The tool library, if we needed to add a new tool to the system, we would have gone to tool library, and that way it adds to the system and saves. But what we're going to do is we're going to pull tools from the tool library into here. So I'm going to start with let's start with the the face turning tool. It's just going to be a CNMG, just kind of a standard roughing tool. So I'm going to go to the rough category. I'm going to add from the tool library, and I have 3 CNMGs with different radiuses on their nose. So I'm going to use this 1/64 CNMG here. And again, you could, just like with milling, you double click on it and you could see all the specs about that tool. You could see what the holder looks like. If you need to make changes to the holder, which usually with the OD stuff, this isn't super critical, but when you get into ID stuff, and you're starting to pick ID turning tools, a lot of times the default holder that's on here, this big guy, is too big for your parts. Right now, A is the width from basically the front to the back, it's 1.25. So unless you have a hole that can accommodate that, you're going to collide with your part often, and it happens all the time. So you have to come in and make better holders. Now, holder geometry in BobCAD's a little wonky. It does create them as rectangular, so it's a little odd. But there's ways around that. If you've ever looked at a program, or it's a website called Machining Cloud, it's machiningcloud.com. You can actually go on there and pick out your tools from your vendor, usually from your vendor with the holders that you're using and everything. And we can actually bring those into BobCAD as models that you can use. You can actually import them, I believe, into your tool crib back there. So we'd have to look there. But if you need to change anything, this is where you change it. Just click on the picture or click on the box and it'll update the image and show you what you're changing when you make these changes. So I'm going to go with that tool there, and I'll hit OK. All right, so that's going to be my roughing tool. Now I'm going to go do my finishing tool. So I'll say add from tool library. And this one's going to be just a VNMG with a 64th rad. So it goes from an 80 degree down to a 35. And again, double click on it. You get a picture of it. Scroll down. You'll see the whole tool right there. And if there's anything wrong with that, this is your time to fix it. If you don't fix it now, you kind of get stuck with this holder. And one of the big things that's very important, hold on, let me get this microphone in my face. There we go. One of the things that's very important when you're setting this up is that you do have the correct holders, because we're doing collision checking with these holders. So we want to ensure that we have a holder that can be adjusted, and BobCAD will automatically adjust for that. So I'll go ahead and hit OK. And if we go to all tools, now we have our roughing tool for the face. We have our finishing tool for the face, which will also be the roughing tool and the finishing tool for the OD. So I'll use that, no problem. For the drill, I don't need to worry about setting up a drill, because I'm just going to define the diameter and BobCAD will create that for me. But if I don't set up a center drill, it will automatically pick a number 5 center drill every single time. So I'm just going to add from my tool library, and I'm just going to go ahead and pick my 1/2 inch 90-degree spot drill, because I'm going to use this to put a little chamfer on the, or a little chamfer right on the front face of that hole. Just a little 10 thou, 20 thou chamfer, nothing too crazy, just something to break that corner. Now, again, I don't add a drill in when I do this usually, because BobCAD will pick a drill. Now, we then need to go add a groove tool. We also need a groove tool, so we'll add from our tool library. And we have a few in there all automatically. The difference is this is a face groove. So if we open this up, you'll see it's for face grooving. We have the ID grooves, which is going to be more like a hook, kind of like a face groove, but it'd be turned a different way. And we want to use this one here, just the OD groove right there. Now, this one is super important. The holder on these, if we edit the tool holder, we can see that the stick out on there, the A right here, is only 5/8 of an inch. If we were going deeper than that on any of our grooves, it will adjust the tool path to assure that we don't hit the part. But by adjusting the tool to make sure we don't hit the part, we don't end up cutting all the geometry. So if you have a longer stick out on your tool, or maybe your grooving tool is one of these center cutters, whatever you got, there's different types of holders inside of there. I'm going to go with the standard one. The only change I'm going to make is I'm going to say that it sticks out 3/4 of an inch. I shouldn't need it. All right. The groove that I'm cutting is not that deep, but, make it as realistic as possible. And especially if you're in the library now, this is the time I would spend to make my tools correct. Make them as best you can. That way on the next job, tomorrow when you do a job, this tool's in there. And this tool matches because you set it up properly the first time. So I'll go ahead and hit OK on that, and then hit OK once again on there. And that's going to bring in just my grooving tool. So now let's look. We got our center drill, our rough tool, our finish tool, our groove tool. I think I said that already. And so the last thing we really need is that cutoff tool. So the cutoff tool is also important. If you do not put one in, it will pick the grooving tool to do it. And I only have 3/4 of an inch, and this thing's 2 inches in diameter. So I wouldn't have enough stick out on my tool to actually do my cutoff. So I go down to cutoff, add from the tool library, and we only have one by default. It's 3 1/4 inch length. So if we go in here, we'll see, actually, this isn't even right. It's a 1.62. I may have modified that. Let me not say that. I may have modified that to 1.625. Which in this case, I'll just say, let's have it stick out. I'll do what it defines. So it's a 3.25 length. And then that's it right there. Now you got to think here, the shank length right there, that's the total length of it. And then you have your width. So if you had a longer tool, this shank length would be, get greater. That's now 8 inches. And then your width is 1 inch wide. It's kind of the overall. So I could say 0.75. And I could shrink that down. Again, you just want to make it as realistic as possible because it's going to help everything. So you have your shank thickness, which is actually the thickness in our view right now, if this is X and this is Y, the thickness is Z. The only time you'll really see that, though, is inside the simulation, which it can cause problems when you're doing ID work. But normally it's because I don't have a shank thickness of 1 inch. It'll be a shank thickness of, maybe a ½ inch or something. So you want to set that up. Again, just bring the tool to the desk with you and just define it as best you can. All the code is based off of the hypothetical point in front of the tool, but one of the settings we have is the ability to compensate for the tool holder. So it's kind of, there's that to it. So I'm just going to go ahead and hit OK. And if we go to all tools, now we can see them. So we got our CNMG for roughing, VNMG for finishing, center drill for the hole. Again, the drill will automatically be selected. We have our 1/8 inch 64th rad OD grooving tool and our 3 1/4 inch 1/8 inch wide cutoff. So now I'll hit OK, and that sets up all the tools for the job. All right, I'm going to go ahead and take a drink break. Give me a second. All right, so now that we have the stock created, we have our tools set up, this is when we'd start doing the actual machining on the job. All right. All right, so we now have our stock created, we have our tools created, and now we're going to go in and just start the tool path. Let's face this bad boy off. And just like the facing pass for mill, when you right-click on Machine Setup 1, there's a feature specifically called Lathe End Face. This feature looks for geometry in front of that origin that we created. So we have 100 thousandths in front of it. If you do not have any geometry in front of it, this tool path will do absolutely nothing. Just a heads up. So we're going to go say Lathe End Face. We're not going to pick any geometry on this one. It's recognizing our drawing up into the y-axis coordinate or the x-axis coordinate, whatever you want to call that line. And if there's geometry, if there's stock in front of it, it knows how much it needs to machine off. So we'll go ahead and hit next. Right here for the feature page, it's all set up for facing. So the rapid plane is the rapid plane in front of the part. So to rapid and make other cuts, we're going to go 200 thousandths out from the face of the part. Now we're doing a feature type of a front face because it's the lathe end face feature. And then you could tell it how you want to cut it. So you can either go from the OD towards the ID, so from outside to center, or if you go to region 2, you'd go from center to outside. All right, just depends on how you want to do it. Right here we have our constraints. Now, we'll see more with the constraints in the next tool paths, but the constraints allow us to choose whether we calculate from the stock, so we let the system look at the stock and machine it, or we could go with custom. Now, custom is one of the ways that you can get a tool path to come out without the geometry being there, but it's so easy to add that face geometry when you're setting up the stock that it's the way that I would always do it. So for me, my constraints for at least my first couple tool paths are usually from stock. I want it to recognize where the stock is, and I want it to machine that all away. Now right here, I want to do region 1. Right here we have some extensions, and extensions just allow us to add a little bit to the front face. So maybe if we define this as 2 1/4 stock, maybe it's a little bit, or actually your stock is even bigger than that. But maybe your stock's a little oversized. So what I could do is on the start, I could say, let's give it an extra 1/4 of an inch. So it's going to lead in a 1/4 inch above the part. So your leads are going to be off the part, as they should. It'll lead in, and then it'll add just a 1/4 inch of straight geometry. That's at the start of the cut right here. The end is to go past the center. So you're not leaving that little tit on the front of it right there. So we could go in and say, I want to go just an 1/8 inch past center, and then it's going to lead out from there. All right. So that's an easy way to make sure you don't accidentally plunge into the material, especially on your first face. You haven't done any OD work to really bring it to size yet. So this could be something that you might have to do. All right, we'll go ahead and hit next. Now for the machining strategy with this face, you have 2 options. You can rough it, or you can rough and finish it, or you can run just a rough pass. I guess 3 options, or just a finish pass. I'm going to go with just a singular rough because I don't really care. I mean, I'm just facing it off. And then the rest, a lot of the geometry is going to disappear after that afterwards anyway. So I'm going to go with just a rough. I don't care about the finish that much. And we'll just hit next. Now for the posting, we have separate moves, which is, think of that as longhand code. Every move is going to be defined in the code. We also have CAN cycles. So you can use like what is it, G71, G70, G71, I don't know. You're roughing CAN cycles. These all depend on your post processor. You have to make sure that the post has the ability to output the correct CAN cycles for your machine. If you're new with Lathe, or you're still pretty fresh with it, CAN cycles are good and bad. I personally, I can't read CAN cycles well. It's not something I've had experience in. So most of the time when I output, it's going to be separate moves. But CAN cycles give you the ability to have a short set of code with everything defined. A lot of guys that I've worked with like it because they could go make real quick, easy changes to the CAN cycle itself, and it changes how they cut their parts. With facing passes, you'll meet guys that run their lathe. They don't even add a facing pass in their software because they're just going to walk out to the machine, do a quick MDI, CAN cycle, and just face off the part real quick. Get it to size beforehand. So one thing to note, when you use CAN cycle in here, you will lose some options on other pages. They're not options I use super often, but I'm going to go with separate moves just because it's, for me, easier to see in the code, easier to read. And then I'll go next. Right here, it grabs tool number 1, which is our CNMG. You can click up here to show your tool holder, all that kind of stuff. So pretty standard stuff. We've already defined all the tools. Now, the orientation of the tool, this is going to kind of determine whether you're doing ID or OD style cuts. But a lot of times when you're doing that, these will be set up automatically. So right now we're going to go with a vertical tool. That's what we want. But we could do a horizontal tool as well, maybe for a different kind of cut, depending on what we want. And then right here we have our tool number, our spindle direction, so clockwise or counterclockwise, and then our coolant type as air, mist, oil, or flood. And then finally the feeds and speeds. Now, feeds and speeds by default, they're always going to come up. Why am I in meters per minute? I'm in inches down here, and all my values are showing up as inches. That's odd. I'll have to look at that. Yours, I don't know if yours is doing that, but that should show SFM, not SMM. What's yours? Did yours show that at all? Or are you getting SFM? Yeah, either this is all going to be wrong or yours is correct. All right, good. All right, so I'll leave it. I'm just going to go with RPM mode. We'll do our maximum RPM, and then I'll say my spindle RPM is just 500. So, yeah, we'll try it that way. Feed rate should be the same. Feed rate's 15,000. That's why I kind of know that there's something wrong here, because the 15,000 is staying the same, which is very odd. I'll have to report that one. Here, give me 1 second. Let me slap a screenshot of this so I don't forget later on. Where are you? There it is. New Lathe wizard, son of a gun. Hold on. Got to click on constant surface speed. There we go. New, slap a picture there. And then let me just draw with my red pen. Hey. All right, perfect. Got it. So after we set that up, we're going to go ahead and hit next. Right here for the patterns. Now, this is where you get into some stuff that, honestly, a lot of guys don't use this. But if you got the right tooling and you got the capabilities of it, absolutely. So your standard and standard is your standard. This is the way you should think of it. A standard cut is going to make a cut, or in our case, it's a face cut. So it's going to make a cut down the face, go in, make the next cut, and that's about it. But we could also do an offset. So the way I explain this to guys is it treats it kind of like a pocket where it follows the shape of the geometry on every cut. You know, with the standard, you're just shortening your cuts, and then the finish pass is what's really going to lock that shape in. But with the offset, you're slowly offsetting that shape in. So even on your final rough pass, you'll still have a pretty decent finish. But again, usually go with standard. And then with your sorting, you could go with standard, which is, start at the top, make a cut, go back, make the next cut, make the next cut. Standard. Easy. You could also use a zigzag. So this one's going to make a cut, and then on the second cut, it's going to kind of back drag. So that one, you just need to make sure you have the right kind of tooling that has the ability to drag backwards. In our case, we don't have that kind of tooling, so we'll keep it on standard. Now, this is the big one. This is important. If you're not lying about your tools, all right, as long as you define that tool and you define that holder and it's real, then you're going to want to change this option right here. Right now, it's called on without collision detection. So you are using the system to compensate for the tool, but you're doing it without making sure it's going to collide. So what we want to do is say on with collision detection. So now it's using that to ensure that we don't drag the back end of the insert across the part. But we can also say use the tool holder. And that's going to make sure that the back end of the holder doesn't accidentally drag across the part. This will fully change the tool path as it cuts. It'll change how it runs. You'll see the adjustments. If you ever do a groove and for some reason you have this weird angle in your groove, it's because the length of your groove tool is not long enough to get to the bottom of the groove over a wall. So it'd be like our grooving tool would hit this wall right here, but it's fine if it goes over here. So you'll have like a weird angle in the floor there, and then the rest of your groove at the right level. So this is just really, as long as you're, again, not making up just fake tools, then go with the system compensation, on with collision detection, and then make sure to check that button for use the tool holder. All right. When we're done with that, we'll go next. Right here for the parameters, we have our depth of cut. So this is just anything, it's what you're comfortable with the tool taking out per pass. This is going to depend on the material you're using or that you're cutting. You're probably running carbide or ceramic inserts or something. So, we have those taken care of. So it's your depth of cut. It's what are you comfortable taking. The rough allowance is allowance being left on the part for another rough pass to come in and clean up. We're going to focus here on finish allowance. We left 100 thousandths. I do not want to leave 10 thousandths worth of material. So for the allowance, we're going to set these guys both to 0. We're not using that rough allowance unless you check that box. Now the overlap, I'll talk about that on the next one. You have some chip break options. So you could have it break or basically lift the tool at a certain length of cut, a certain amount of time, or a certain length of chip. All right. So I'm just going to go ahead and hit OK. And I'm not going to do any chip breaking right now. Right here we have our corner types. So I believe I talked about it. If you're in the milling course, it's the corner type does not ever really change the corner. What it does is it changes how the tool interpolates the corner. So either we go with a sharp move or we go with a round move. All right. And that's just going to be, again, that's just the interpolation of that cut. And then right down here is an option called trim to stock. This essentially allows us to bring in a secondary model that, maybe you're doing a job that's already had some turning done to it. Maybe you're just cleaning up a part, doing something like that. What you could do is you could draw two parts. One that's the final, complete, finished part that we want, and the other would be a part file that represents what the stock looks like. This is big when you're doing like a casted part. You got a casting that's got extra material on it. You draw out the normal part that you want to finish to, and that's what you'd select for your geometry. But for your stock and for this trim to stock option, you would show us a copy of the model without with the casted material still left on it. And that way BobCAD could just recognize where the material is. So instead of doing cuts like this, you could faintly see it in the background there. That's the stock there. And if we don't trim to stock, we waste all this time cutting air. But if we trim to stock, the system knows where that stock is, saves you a little bit of time. Next, again, we get to the Rapids page. Now, the Rapids page, by default, is going to be set to default rapid on the approach and a default rapid on the exit. If you're doing all OD cuts like we're doing here now, you're probably fine with this. The only thing you'll have to worry about is making sure your home positions are right. If you're doing ID cuts or just getting into some crazier things, when you click this drop down, especially on the exit, you'll see all these different options. So we could rapid on the exit to the tool home. We could rapid on the exit to the cycle start. We could rapid to a defined point, or we could do no rapid on exit. Now, the letters that you see after that, X-Z, Z-X, and XZ, what those are telling you is if I said rapid on exit to tool home X-Z, it means X moves first, then Z, or Z moves first, then Y. And on the one that doesn't have a dash between them, that's the same at the same time. Move X and Z at the same time. The only time I really mess with my, really either of them, honestly, really the only time I mess with either of those options is when I'm doing ID work, and it's only sometimes. It's when I watch the simulation and I see it exited the wrong way to get out of the part. Then I'll come in and manually take over, and I'll pick the lead out or the lead in that I want. All right. So I'm going to leave that most of the time with the default rapid on the approach and the default rapid on the exit. And then we'll go next. Right here for our leads, we got a lot of different leads, parallel leads, and it's parallel to the cut, basically to the entity that comes before it. So if you had an angled piece of geometry that you picked, and that was what we're leading in on, the parallel is going to follow that angle. Perpendicular is going to be perpendicular to that geometry. This picture shows it perfectly. It's perpendicular to that geometry. A parallel is parallel to that angle. Then you have a horizontal, which is always going to run along kind of the 0 degree axis, really along the Z axis. You have a vertical, which is going to run along the X axis. You have an angle that is 45, apparently. It's always 45. I thought we had an adjustment there, whatever. And then finally you have custom. And custom is how you'll get custom angles on lead outs, because it looks like angle is always going to be 45 degrees from what I can see. So custom allows you to say that I want my X to go, 0.1 and I want my Z to go 0.2. And that'll be, that angle. I don't know what it is. I'd have to draw it out and measure things. But there's math that can do that. I don't know it. And so lead in, I'm going to leave it on parallel. And on my lead out, I'm going to go with a horizontal lead out. We've already extended this. If you remember from the beginning of this, we added, I think I did a 1/4 inch at the beginning and an 1/8 inch past center. So I'm going to go an 1/8 inch past center, knock down any tit that's going to be left there, and then come straight off the part in the Z axis. That's fine with me. So when we're done with that, we'll hit next. And Brock, what kind of machine do you have? Is it, who makes it? Is it Haas, Fanuc? What maker is it? Hyundai. Okay. I don't know if they have an issue with dogleg rapids. Normally when you hear about it, it's Haas. So you shouldn't have to worry about this, but I'll put this in the video anyway. The convert rapids to feeds is to take care of an issue called dogleg rapiding, where the machine isn't rapiding in a straight line. It's rapiding in kind of a set of angled lines. That's all it is. This essentially lets you take out all the G00 rapids in your code and replace them with G01s, and you enter a feed rate. Right here is your lead in and lead out feed rate percentages. These are a percentage of the cutting feed rate that's just used when you're doing a lead in and lead out. All right, are you all caught up? You're on this page with me? Perfect. Hit compute. It will take a minute. It's because we didn't define any geometry, and really it's actually the compensation that we're doing. The system comp with all the collision checking. It makes the toolpath take a little bit longer to calculate. Just sit there, just wait. It'll finish up eventually. The better your processor, the better your calculations will be in your computer. So if you're using a laptop or a desktop, that'll make a difference. I'm running on a desktop, but the processors, she's getting old, and she's not running as nice as she used to. So it takes an extra minute longer. So there it is. At this point, very important, and I don't think I say this enough during these things, save your part. All right? Go up to File, do a save as. I'm going to do a save as. I'll throw it here, and I'll say, actually, let me put this in the folder for the repeat trainings that I do. So desktop, repeat training documents, BobCAM. All right, so let me add a new folder real quick. BobCAM, whoops, V9 Lathe. What's the date today? 12, oh, just kidding, 11/18/2021. Oh, man. So we'll save that, and I'll say Toolpath. All right, save that now. So make sure you just save a copy just in case. Yeah, don't show me that again. Thank you. So just make sure you save a copy just in case something happens. And pretty much the rule of thumb I follow, just so we know, and I will forget about it, but the best rule of thumb I've come up with for when to save, when you finish calculating a toolpath. All right, calculate your toolpath, save. And then after you've done all that, before you launch your simulation, save. During calculations and during simulation loads, those are the two times that my computer sometimes struggles. And it all really comes down to just, I have an older PC at this point. I'm hoping to get new one next year. We'll find out. So just make sure to save often. That's the best advice I could give anyone. Anyway, so when we're done with that, let's go ahead and blank it out, shrink it up, and there we go. So now we're going to go in and do the turn rough around the outside. All right, so we're going to right click on Machine Setup 1, Lathe Turning, and we're going to select our geometry. Now, for you, Brock, you're just going to pick the chain like I showed you earlier. For me, for SolidWorks, if you're doing this inside SolidWorks, you have to pick every surface along the edge that you want to go. All right, so we just pick everything. I'm even including the chamfers and the groove. Though we don't want this toolpath to cut the groove, we do want it to know that it's there. And we can actually avoid it. There's a real quick, easy feature to avoid your grooves. So I'm just going to pick all this geometry right here. Almost done. Just like that. So if you're using that standalone, you want to make sure to pick all that. We do not want anything on the back, and we want to start it on that front fillet there. When we're done, we can hit OK. And then hit next. All right, I'll pause right here. Let me know if you're still caught up with me. I figured you would be. It's easier to pick that geometry anyway. All right, cool. All right, so the rapid plane's at 200 thousandths. That's 200 thousandths above the, above the top of the stock out there, the OD of the stock. The feature type we're using is OD, but because this isn't a specific feature, like the lathe end face is specifically for the front face, this one lets you say it's an OD cut, it's an ID cut, it's a front face cut, or it's a back face cut. All right. And you can choose then, if you're on the OD, you could choose to go from the front face of the part back towards the spindle and the jaws, or you can go from the jaws and the spindle backwards, so towards the front of the part. We're going to go with region 1, OD region 1. And then right here is the section for grooves. Grooves inside of your turning geometry are technically undercuts. So what this is it's a remove primary and remove secondary undercuts option. Remove primary undercuts tells the system to ignore any turn grooves. So any grooves that are on the OD kind of, turn. Remove secondary undercuts removes any face grooves. So for us, we don't have any face grooves right now, but it's not going to hurt anything to turn it on. So what I tell people, just run both of them. We want to avoid all grooves. I just want to basically use this to rough out and get us the basic shape of the part. Well, we're going to do a finish pass as well, but get rid of a majority of the material, and then all we have to do is clean up the grooves afterwards. Right here we have our constraints once again. So this time we have a new option called from geometry. So from stock is again just saying take all the material out wherever the stock is showing that there is still material there. All right. From geometry uses the height and kind of the height and width of the geometry you select, and that will be its maximum bounds for the cut. That's something we primarily use on like grooving. I'm not going to put a groove in before I've done the turn rough on here. So I'm going to do my turn rough, do my turn finish, and then I'll come back in and add the groove. But the groove will work from the geometry that I select. So the highest points for the groove when we pick it will be those two chamfers in the corner. All right. And then finally, have custom where you can define the height or you can pick it from the model where you want to go. For us, we're going to go with stock or from stock. And then I am going to add some extensions as well. I want it to start a little bit in front of the part. We'll say just 1/8 of an inch. And then I always like to have it go past the end of the part a little bit just to make sure I get a nice clean cut. So I'll just go, we'll say 1/4 inch is what we'll do. 1/4 inch distance past on the end. And that'll give us enough of a cutoff or enough of a cut that when we do our cutoff, it's not encountering, thicker material than it needs to. All right, so we have that. We'll go next. Now for the strategy, you have three tool paths that you could use. You have a rough pass, you have your basic finish pass, and then you have a pattern repeat, which essentially takes the final finish cut and it offsets it out. I usually just go with this option right up here that says rough/finish, and we pick it up here because it automatically gives us the rough and the finish pass. I'm not going to do any pattern repeats today. So we'll go ahead and hit next. And now we have our posting. But you'll notice on the left here, we now have a rough here and that basic finish. So it added that basic finish in for us. I'm going to go with separate moves because it keeps all my options available to me. And I'll go next. There's my CNMG. Easy peasy. It should grab the same tool it used when we did the face pass. So there we go. All right, give me 1 second. I need a drink. All right, so tool number, all this stuff is the exact same as the first. You can see I even have this surface meters per minute, which is something wrong. And we'll go next. So again, the same patterns, but the images will kind of look better this time. So we could do an offset cut, or we could do an offset with a zigzag, or primarily I'm always going to leave it on standard. Right here for compensation, again, the rule of thumb I follow is as long as you're not lying about your tools, you should always be setting this to on with collision detection using that tool holder. All right. And we'll go next. Right here for the parameters, your depth, it's the toolpath we're going through right now, just in case you didn't notice it, is the exact same toolpath as the face pass we did earlier. The finish pass is where it'll get a little bit different. So depth of cut, I'll leave that at 50 thou. I'm fine with that. But because I do have a finish pass this time, I'm going to leave the 10 thousandths in Z and in X. Now the overlap that you see down below, this is the overlap options. So no overlap is going to just make a cut, and when it gets to the end of its cut, it's going to back out and leave. Custom distance allows you to define a custom distance in which you overlap. So I'll show it with two previous cuts. So two previous cut is the best way to get rid of the steps that would normally be left in the part if you just did the no overlap. Because you think the tool just runs in and leaves, you're going to leave a bunch of steps on this part. But two previous cut, the lead out that we see right here is not the lead out for this chain like it is in no overlap. This lead out here is actually for this chain below. So this chain goes straight across, extends up, and then backs out there. This chain below that will come across, up to the previous cut, and then exit out. And that's the best way to kind of prep it for the, basically for the finish tool. You're getting rid of all the abrupt, sharp edges you might be leaving just running a tool into it. It's like if you've ever done a zigzag on a mill and you do it inside of a pocket. So you just zigzag back and forth when you do your cuts, you'll end up with just like an end mill mark and an end mill mark and an end mill mark. That's what the no overlap is essentially doing. You're not finishing it after that. So it's just something to do. It doesn't add too much time out of the job. I mean, it can. It all depends on how big the part is. But it'll make it easier for your finish tool coming in later on. Again, we have that chip break option. We got the corner types and the bounds. We won't change any of that. We'll go next. Right here, we have our rapids. Like I said, one of the big things with the rapids is I try, and this is kind of my rule of thumb for all tool pathing, I try to change as little as possible. I didn't even change my depth of cut. I'm pretty confident that I could handle a 50 thou of material, but if we wanted to be more aggressive or less aggressive, I didn't change any of that stuff. So I really, my school of thought is I'm not going to change it until I see a problem that it causes. So unless the default rapid on the approach and unless the default rapid on exit cause me a problem, I'm going to use them for every feature I do. So get used to this page, just glancing at it and then hitting next. Same rule of thumb for the leads. At this point, I'm not thinking about it that heavily, but parallel should work and an angle should work. I have no issues with those. We're also extending it from the beginning of the job. So I'm going to leave it with the defaults. Why change it? If it ain't broke, don't fix it. And that'll be the same rule you follow with your 2-axis, your 3-axis mill, and then even, lathe, anything you do. We put these values in here for a reason. They're the most common values that we run across, and they work. So unless you see a problem occur because of one of these settings, you're probably not going to change it. Or I'm not going to change it. And we won't know if there's a problem until we compute the toolpath. And even then, you might not know it until you simulate. So right here for the advanced feeds, again, you got the convert rapids to feeds and the lead in, lead out feed rate percentages. Next, again, we have our finish tool. This should pick the VNMG for us, which is what we set up for our finish. And the reason it is picking the correct tool is because the basic finish is looking for a tool from the finish category. If we had not put a tool into that tool crib finish category, then it would just make up a tool. All right, so this knows that's the tool we want. Right here for the patterns. All right, so for the finish pass, we have two kind of patterns for this. We have a continuous cut. It starts at the front face of the part and it just cuts its way all the way back. Or we can go with an alternate, which allows us to do both directions. Face the verticals only, so it's going to back drag the faces and then turn the diameters. Or like I said, with both, it'll do both of that. It'll turn the diameters and face the faces vertically. Right here for compensation, we're going to say on with collision detection using that tool holder. There's not even a question on that one. We'll go next. We have our finish parameters. So this is what we're leaving for the allowance. If we're not trying to finish the part right now, we need to leave allowance. If we are, we leave it at 0. Chip break, corner types, trim to stock. Next again, we have our rapids. Next again, we have our leads. And next again, we have the advanced feed rates right there. So go ahead and hit compute. We didn't make any changes to that last bit. So compute it. And there it is. Now with yours, you have extra stock above your part. So you should have a few more of these rough passes above this area than I do. That's because it is looking at the size of the stock and it's just machining it away based on what it sees. So that's what it should look like. All right, file save. Make sure you save it. And let me know, are you all caught up? You're at this point right here? And if so, is there any questions that you're having so far? Anything that doesn't make sense? Let me know. All right. All right, so we're done with that one. I'm going to go ahead and blank it out and shrink it up. And then the big thing for keeping track of this stuff is renaming features. I always recommend renaming your features. Lathe and face, I don't feel the need to rename that one. That one's pretty straightforward. But this lathe turning, anytime we do a feature, it could be an ID turn, it could be an OD turn, it could be a face turn. It's all these different types of turnings. They all come out with the name feature lathe turning. So if you have multiples, it gets difficult figuring out which one's which. So I'm just going to right click on it, say rename, and then call it OD turn rough and finish. All right. That way, just at a quick glance, I know exactly what that feature is. So go ahead and rename yours real quick, and then we'll go knock out the groove. All right. So for the OD groove, this one's real simple. We're going to right click on machine setup 1 and do lathe groove and select our geometry. So I'm just going to go in and pick the 2 chamfers, the floor, and the walls. Make sure you get those walls in there. So looking at this right now, just to explain something we're going to see here in a minute, we're going to see the constraints box again. And so what it's looking at is the widest point between the 2 pieces of geometry you selected and the height of them. So instead of starting the groove way out here where the stock is, it's because it's all gone, we're going to just have Toolpath right on that groove. So we shouldn't waste a bunch of time feeding through air to get to the groove. All right. So we'll hit OK after we pick our geometry and then hit next. Right here, it's an OD feature, region 1. And that's just really kind of the order in which you're doing your grooves. Or really, it's the handedness to your tool, either left hand or right hand. And then right here, you have the option to rotate your tool. So this would be useful if you had a angled groove, like we see in that picture. You can set up your tool at the angle that it needs to be, and then define that angle here. And then if you ever use this, you'll also need to define the angle of the tool on the tooling page. So, yeah. So for this one, the constraints, this is what I was talking about. From stock is going to make us groove from the top of the stock down, but all of our stock up to about here is done in this picture. So we're going to go from geometry because it goes from the highest and then widest points of the geometry. And then I'm not going to add any extensions. It's not going to hurt anything too, but my leads will be able to do the extensions for us. So we'll go ahead and say next. For the machining strategy, we have either a groove rough or a groove rough with a finish. So we're going to do the groove rough with the finish. Next again. Separate moves or CAN cycles. Again, that really depends on your post processor. Next again. For the groove itself, it picked tool number 6, which I believe is the correct tool. Or not. Actually, I got to pick tool number 4. Why did it pick a different tool? What's the difference? Okay, so it picked a tool that's a little shorter. I don't know. Make sure to go into your groove tools, and we're going to pick tool number 4 there and hit OK. I think we went in that order for you as well, so we'll try it. Spindle direction, feeds and speeds. Still got the surface meters per minute. Next again. So with the groove, we have 3 patterns that we can follow. The first one is standard. Now with standard, you have to apply the sorting as well. So a standard sort is going to be, 1, 2, 3, 4, 5, just right next to each other, nothing crazy. Center out is going to start in the center and then work in the way it's working now. It's going to work to the left, then it's going to come back and do the right side of the groove. The center out alternate is going to go 1 in the middle, then to the left, then to the right, back to the left, and then back to the right. And then skip is going to start at 1. It's going to skip. It's going to make a second cut. It's going to skip. It's going to make its third cut. And then the areas that it skipped the first time, it's going to come back and recut those. I'm going to go with standard. You could also do it with a single pass based on the center of the tool, the beginning, or the end. And that's really if you have like a custom shaped grooving tool that cuts a specific, sorry, I just smacked the microphone. If you have a custom tool that fits a specific groove, then you'd want to use this one. It's just going to press its way in and then come back out. And the result is going to be the groove that, the shape of the groove tool. And then finally you have zigzag. And zigzag lets us zigzag our way down. Not something I have much experience with. I haven't run into too many guys that are doing the zigzag kind of cuts. So we're going to go with a standard pattern and a standard sort. And we are using our tool holder for collision checking. So what this is doing right now is it's just making sure we have enough stick out on the tool. If you do not click this button, we aren't looking at the length of the tool, which this is where I was talking about guys that kind of, lie about their tools. Well, at the machine, they know they have enough tool to do that groove. Maybe they got a 2-inch grooving tool out at the machine, but they didn't make that change here in BobCAD. So BobCAD thinks it's only sticking out 5/8 of an inch or whatever. If they say if they don't check this button, the tool is already compensated for. But if they don't check that button, then they will get an error inside the simulation. They'll see a collision, but those guys don't care. They know that collision will not happen out at the machine because they have the length to do it. Again, if you define your tools properly, use the collision checking. All right. Next, we get to the parameters. So it's our step over amount, how much we want to step over per pass. Again, we have our rough allowance as well as a semi-finish pattern. But I'm just going to say rough it out, and then we'll leave the 10,000ths to clean up. If you're working on a deeper groove, you can go in and tell it to do multiple depths. So you can take out the entire groove on kind of like layer 1 here, then layer 2, layer 3, and layer 4. Just work your way down into the groove. Right here, you can do your processing. So processing is by area or by level. So this image that we see, this is the entire groove, this whole thing here. So what this is saying is finish an area before moving on to the next, or go everything by level. So go 1, 2, 3, 4, and then the 5th one. I'm going to go by area. Your sorting can be either one way or a zigzag, so you can work back and forth. And then you also have the ability to do pecking. So you can tell it what the first peck amount is, what's the initial peck that we want, what's going to be the increment after that peck, and then what is the clearance that we want to go, as well as any sort of retracts if we want to apply that. And then we also have the trim to stock option, just like before. But this should be taken care of because of our from geometry option. So we'll go ahead and hit next. Here's that Rapids page. No changes. Next. Leads. We only have a parallel lead in and a parallel lead out. So good. And finally, the advanced feed rates. So then we get to the groove finish, and notice it's picking the wrong tool. These two tool numbers should match each other. This one's tool number 6, my other one's tool number 4. So I want to go up to the tool crib and make sure that I pick the same tool I used before. All right. And you can show the holder if you want, feeds and speeds. Next. Right here for the patterns on this one, we're kind of just down to a normal finish pass. This doesn't treat it like a groove. It treats it like a turn tool. So you can do force down cutting, which is starting from both sides of the groove. You're going to plunge in and cut to the middle, plunge in, cut to the middle. You could even add an overlap amount in which they overlap each other to make sure there's nothing left on the part afterwards. You could also just do a basic finish, which in this case starts on, say, the left side of the groove, feeds across, comes out on the right side of the groove. Totally up to you. Depends on what you want to run. For the compensation, there is no on without collision detection in this toolpath. So it is either off or on with collision detection. And again, we're going to say use that tool holder, and then we'll go next. For the parameters, we have our allowance. We'll leave that guy at 0. We got our corner types, no changes, and our bounce for the trim to stock. Rapids, no change. You got it. You guessed it. I'm just kidding. The leads are, we're going to plunge in with a parallel lead, and then we're going to come in with, we're going to exit out with an angle out, or, a parallel out might work because we have these chamfers, so we can just continue on the chamfer. Again, if you don't know, don't change it. Just leave it and watch the simulation and see if it's going to cause a problem. Next, again, we have our advanced feeds. No changes there. So we can hit compute. And we're just going to wait a second. And I want to, before I even really talk about it, I'm just going to go up to File and Save. How do I look down on this? Right. I can't look at it that way. My orientation. Difficult. Come on. So that's what it should look like. And a way to look at this kind of individually is blank out your feature, hide the feature, and then click on the individual operation below it. So this is my groove rough right there. And this is my groove finish right there. Now, I want to point this out to you because a lot of guys don't know what this does. The fact that this is cutting through the wall right now does not mean that you're gouging your part. It means that the hypothetical tip of the tool, and it shows best with this, well, let's see. Let's look at the finish pass on this one here. Basic finish. I got to get the good view. So you'll see it right here, all right, like how it's inside the part. And if you have the wireframe, you'd see it's inside the wireframe there. Well, you got to remember that all of the code is based on that hypothetical sharp corner, the tool tip of your tool. So when we go in, if you ever want to double check this and see how it looks, right click on your feature and say back plot. And then I'm going to try and look at this right, kind of straight on. And as the tool comes in, notice right there, the point would be calculated with a tangency. So it's tangent off of here, and it's tangent down from there. And that hypothetical point's out there. The hypothetical point is what runs along that green toolpath line. So sometimes the hypothetical point is inside the part. Other times it's not. So you can see right there, though we have a rounded corner, the edge of the tool stays on the edge of the part. All right. So it is something that's a little scary when you don't know about it. But what you don't know, now you know. All right, so we'll shrink those two up, and there we have it. So yeah, don't be worried if you ever see the green inside your part or inside your geometry. When you run the simulation, you could run it just run the simulation and take a look at it. But it's because that hypothetical tooltip. All right. Give me 1 sec. I need a drink. Are you all caught up to this point, Brock? You got all that, right? Nothing missing so far, right? Good to go. Awesome. And is it working for you? Because I know you're using the other version. Is this all? I mean, they look exactly the same when you get the menus opened up. So hopefully it's. I think you'll be fine. All right. Perfect. All right. So now let's go ahead and let's drill the hole because we haven't done that yet. And so we're going to right click on Machine Setup 1, and we're going to do a lathe hole. Now, if you're for the standalone version, when you say select geometry, all you have to select is the point where the V hits. That right there is enough. All right. So for your wireframe that you have, you're just going to pick that point where the tip comes down. In SolidWorks, though, I could also pick this wall, and that wall will tell me the diameter of the hole, but it's a little off on this one. So when I hit OK, all right, and then hit next, we need to set the diameter. By only going and picking the point in the back, it would know the depth, but it doesn't know the diameter. The diameter of this hole is 1/4 of an inch. So just put your diameter at 0.25. Right now is the time you want to get your diameter set correctly because BobCAD is going to pick the drill based on this diameter that we just entered in. And then for my total depth, I'm going to say pick bottom. If you're picking the wireframe point, it should be there, and it should be about the same at this 0.6612. That is where I want the tip of the drill to stop. That's important to remember because we're going to need it in a minute. It is a blind hole. It's not going all the way through the part. Remember, if you use a through hole, BobCAD automatically adds 50 thousandths onto the end of the cut. So we want to make sure it's blind so we don't add any extra distance. Next, again, we have our machining strategy. I'm just going to go ahead and choose the lathe hole, which gives me a center drill and a drill. Next, again, we have our posting, separate moves or can cycles. Most posts are probably going to have the can cycles for drilling, probably right off the start. But if you have if your post isn't a normal post, then it could be a little bit different. Next, again, we have our center drill, which is our number 5, or sorry, not our number 5. It's not the number 5. It's our 1/2 inch 90-degree spot drill we set up, tool number 3. And again, the feeds and speeds for this one are calculated the same way they are in milling. So we're looking at the tool material. We're looking at the material that's chosen inside the feature here, and we're calculating the feeds and speeds based on that. So we'll go next. Now for my center drill, I picked my 1/2 inch 90-degree spot specifically so I can use it to put a little chamfer on the face of this hole. So I'm going to go ahead and just say the distance, it's a 1/4 inch diameter. So I'm going to go to the center diameter I want to be left when I'm done with this job is 0.26. All right, good so far. Perfect. And then we can choose whether we want to pack or fast pack or just single depth. I'm only going 130 thou deep. I'm going to single depth it and go next again. For the rapids, we have our default rapid on the approach and our default rapid on the exit. You know this. You know the drill at this point. Just next, and then it picks the drill. So it automatically grabs this 1/4 inch drill for me, does the feeds and speeds calculations. Next again. For the parameters, now this one's important. Notice the numbers right now. Now our effective depth is 0.6612, and our overall depth, where the tip of the tool is going to go, is 0.7363. And that's because it's adding the length of the tip of the tool on. So I'm going to uncheck that button, and I want my overall depth to be 0.6612. And so the adjustment that you'll see, this 0.5861, that's the length of the full diameter hole, and then where the taper comes in is going to be at, the 0.6, from there to 0.6612. Again, you can choose to peck or fast peck, and when you're all done, hit next. Again, we have our rapids, and finally compute. And there is a that's an arrow. I thought it was some weird toolpath. If you saw that, it was looking weird. I didn't realize those arrows were all lines. Look at that. Pretty nifty, eh? So that's just an arrow telling you which direction it's coming in. And the drilled hole. So we'll go ahead and blank that guy out and shrink it up. And finally, the last thing, and we're finishing just in time for the lunchtime to start. Last thing we're going to do is the cutoff. So we can right-click on Machine Setup 1. We're going to go down to Lathe Cutoff. Select Geometry. And I have a point back here that I drew earlier. That's my cutoff point. If you're using the wireframe, you're going to pick that bottom left-hand corner, hover over one of the lines till the snap point pops up, and then click on it. And then hit OK. Now, if you didn't draw that snap point, or if you didn't have that point dead center, if that point was shifted up to, say, here, you're telling it where to cut off in both X and Z. So I'm telling it, by picking the middle point, it's going to cut off all the way back here in X and all the way to the center for Z. Or, sorry, I did that backwards. All the way back here in Z and then all the way down in X. But again, if that point was up a little bit, you could say, I want to cut all the way back here in Z, but I only want to do a cutoff of, I want to leave some material holding on to it afterwards. So it's up to you. So we got the geometry. We'll go next. We got our rapid plane. Right here's our feature type. We can go from stock or custom, which custom is sometimes needed if you're going to use this cutoff tool to do a chamfer or a radius on the back of your part. If it reads from the stock, and especially like on your part where we have a lot of extra stock, like a 1/2 inch of extra stock out here, we would want to make sure to choose custom so it knows where to start the radius or the chamfer from. All right. But in my case, I'm going to go with from stock. And in your case, I think you'll be okay. We're not doing a radius or a chamfer on the back end, so we're good. So go next. Right here, we just have the operation. It's a cutoff. It's the only operation we got. Next again. For the posting, we have separate moves or can cycles. Next again, we get our cutoff tool. I always like to turn on the holder, make sure it's the right one. Next again. For the parameters, we're going to go Z -3. So it's 3 inches long. That's as long as our part. So we're going to go back 3 inches, and then we're cutting to X0. You don't have to draw the point on the part. You could also just come in and say, I don't want to cut all the way to the middle. I want to go to X.5. And that'll leave, an area in the middle that stays held onto. But for us, we'll go ahead and zero that out. This is our corner break option. So we could do a off, we could do a chamfer, or we could do a fillet. And then we have some pecking options here where we can tell it the first peck amount, peck increment, peck clearance. It's essentially a grooving toolpath, but for a cutoff. Finally, we'll go next, and we have our rapids. Again, use the default rapid on the approach and on the exit. And when we're done, we will compute. And there is our very simple cutoff. Once again, make sure to save, file, save. And there we have it. How'd the cutoff work for you, Brock? Any issues? No issues. Beautiful. That's what I want to hear. All right. So now let's go ahead and we'll shrink this guy up. So CAM's done. everything looks good. So we'll go ahead and start our simulation. Again, if you didn't save just now with the cutoff, save before you launch the simulation. All right, simulation loads up. We're then going to come in. Let me check my stuff here. Current up, segment. So one quick setting if you want to make the change. With your toolpath, when it's showing, by default, it's set up with all ops, and it says, it looks like this. So if your screen looks like this right now, it gets difficult to see what's going on. There's a lot of extra geometry for the toolpaths in front of you. So what you could do is leave the toolpath visibility option on, but go to the toolpath rendering next to it. And what we want to do is right here where it says all op, we're going to change that to current op. And when we click this again, we're then going to choose an option called segment. So what happens is as it cuts, we're going to see the path, but as it finishes the cut, the path is going to disappear. It's just going to show us a segment of it at a time. And that's a really good setting to turn on for lathe, for mill, for all of them, because it hides it kind of hides the toolpath as you're cutting. Because if you ever do a big 3-axis milling job, the part can be so covered in toolpath, you can't tell if it's got a good finish. So you have to be able to hide it. And yeah, you could turn off the toolpath, but the toolpath is really the only option in here that doesn't stay saved. If I turn it off and I open BobCAD or I open the simulation back up, the toolpath will turn back on. So this is a way of not having to turn off toolpath every time. Again, current op there and segment there. And when we're done, we can go ahead and hit run. And you don't want to run this too fast because lathe does run very quickly. So you can see there's our face pass. There's our turn rough, turn finish, groove, hole, cut off, and there we have it. Everything looks pretty decent. I think, yeah, we might have too big of a radius. Oh no, these don't have a radius, I don't think normally. If you ever want to compare this to your solid model, so for you in your layers, you have a solid model that's probably turned off at this point. What you do is in SolidWorks here, you just make sure that your feature itself is showing. If you're using the standalone version, you just turn on the layer that has the solid model on it and then launch the simulation. And what that gives you is the work piece. All right, so the work piece inside the simulation here shows me a copy of the model we did all of our tool pathing from. So I'm just going to speed through this and run it. And what we'll see is that white and that blue. All right. That's what we want to see. You always want to see the white and blue kind of showing through at the same, in the same area, because that means that the simulation really doesn't know whether to show you the work piece that you created or whether to show you the part that you've cut. So overall, that looks pretty good. Now that we have that done, we've gotten the simulation. Had we found a problem, we would have want to first find out which one was causing the problem. If it was, the rough or the finish, whatever it is. If there was a problem, you would just double click or right click and hit edit on your feature, and you would go fix whatever problem you have. If it's a leads problem, fix the leads, whatever. After you're all done, all right, and we're ready to see the code, we're just going to right click here on turning job. And the first thing to look at is the machining order. All right, so click on machining order and look through here. So right now, I believe mine's set up the correct way, but yours might have a different order of some things, potentially. What we want to do is, the way I set this up, well, real quick, does your machine have a tool changer? Yep, tool turret's fine. Tool changer, it can change its own tools is basically what we're talking about. So it has a tool changer. Yeah, this is more like, so there's 3 options here. You're never going to use individual tool per machine setup on Lathe because you can only have 1 machine setup. Individual feature is always going to run it in the exact order you put your cam tree in. So we're doing the face first, we're doing the OD rough, then the turn. So we're switching tools to the turn. Now in ours, we don't have that many repeating features or repeating tools. But if you were doing a part where you went from, tool number 1 to tool number 2, back to tool number 1, back to tool number 2, if you didn't have a tool changer, you would have to figure out how to do that. And that's where the individual tool comes into play. It allows you to group the tools together based on when they're used. Or, you get to group the tools together. So they run in that order. They'll do all the rough tools, then all the finished tools, then all the drills and all that stuff. For us, though, we want to make sure we're sorted with individual feature so it goes in the exact order we have the cam tree. Your turret's just going to switch tools for you. So I don't care about that. I'm fine with tool changes happening. I just need it to go in this order, because if something goes out of order, if the groove ran before the basic finish ran, it's not a lot of material, but there is a little bit of extra material on the part that this groove isn't expecting. All right. So we want to make sure we have that right. Or it'd be like if for whatever reason, your face, became, for whatever reason, the last feature you had. Well, now when I go to do my OD groove or my OD turn, I have 100,000 of extra material in front of my part. So individual feature makes it so the order you put in your cam tree is the order we run it in. If you need to reorganize your cam tree because, sometimes you go through a part and you're just trying to lay the tool path down, you're not really thinking about the order you need to machine it in, you can actually grab and drag geometry or grab tool paths and drag them to have them switch positions. So like in my case, I could say, you know what? I don't want to do the groove and then the holes. I want to do the holes and then the groove. So I could grab the groove, drag it and drop it on top of holes here. And now it's going to do the holes, then the groove, then the cutoff. All right. So there we go. Now that we have the machining strategy set up, or the machining order, we're now going to post the code. So we can right click on turning job and just say post. But before you do that, you're going to want to make sure you have the correct post processor. Like I said, it's going to pick this BC2X lathe, but if you expand it, that's the post that's currently being used. If we right click on there and say edit and then select, you can pick one of the posts. If you've gotten a post made by us, it should show up in this same folder. Or if one of these matches the controller you have on your machine, if we're giving them out, they're pretty much good to run. Might need some minor changes. Cancel that. So then I'll go ahead and post my code. And for me, it shows up right here. There is all the code for all of this. I didn't use any CAN cycles. If we wanted to shorten it up a bit, you could definitely run some CAN cycles. And then to save the code, all we do is right click inside of it and say save as. And make sure you put it in the right spot. Let me go to my folder here. Repeat training documents. This is this one. And so I'll just save that right there. And now I have a copy of my code. The last bit is a setup sheet. Now, the only setup sheet you're going to want to use for the lathe module is the full setup sheet. So you go right click on turning job, generate setup sheet, and then there's the full setup sheet. Now, we do also have the tool list. You could absolutely use one of those, but the full setup sheet gives us the tool list, gives us the stock info, gives us everything. So we'll just hit OK. Wait for it to launch. It'll launch inside of Internet Explorer. And there we have it. We have our name of file, the post that we use, the machine, the date and the time, the total cutting distance, total rapid distance, number of operations, number of tools, number of setups, total cycle time at the feeds and speeds we have set up, a picture of the part, and that's just a screenshot of the part. So you could align your screen before you do the setup sheet, and it'll give you a nice picture of it. We got our material, stock information, sizes and everything. The tools and how much they protrude, all the information you'd want to know. Because all the tools that we currently have, they work. They ran perfectly. So if I went to change any of these, like if I didn't have my spot drill sticking out, if I didn't stick it out 2 inches, am I still okay? Yeah, we are. We're going 130 thou deep. So as long as you got at least a half inch of stick out on that, you'd be fine. And then a breakdown of each of our tool paths with a little cycle time next to them all. And it's using my feeds and speeds to calculate that. And then to save this sheet, the way I always do it, if you're on Windows, I want to say Windows 8, Windows 10, or now Windows 11, you can just right click, go down to print, and then use the Microsoft print to PDF and just say print, and it'll actually save it as a PDF. You can come in and save it. So I'll put this in the same folder. Oh, there it is. And machining example 1, Toolpath. And that's going to save it as a PDF. So you don't have to immediately print it out on a sheet of paper right now. You could print it to a PDF, and then now you have a PDF you could open up and mess around with. And after you've saved it, feel free to close down. And then the last step, save your work. There we are. All right. So, yeah. All right. So that's it. We're gonna finish today. That's it for today. We're done. We'll go through that one part. So, thanks for being here.